VGS, Visual Guidance System Application. This video shows how the Visual Guidance System application works, which has been developed within the project Sprints. Sprints, Smart Process Industry Cranes. Sprints is a software project, funded by INAIL, the Italian Institute for Insurance Against Accidents at Work, and the MSD, Ministry of Education, Science and Technological Development of Serbia. The VGS application is a real-time object detection solution. It assists the crane operators in the prevention of collisions. Before starting the application, it is necessary to configure the system. The setting steps are: detection of the cameras, calibration, and setting of the stereo vision. Cameras detection. The cameras detection procedure is realized by the VGS cameras setting dialog box. In the cameras setting dialog box, two camera typologies can be selected. Here, the USB camera, and here, the IP camera. For each camera, the device identification must be inserted in the added text area. The USB cameras have a numerical ID, whereas an URL identifies the IP cameras. To verify the activation of the cameras, click on the button Open Camera of the VGS settings window. Calibration. Stereo calibration is a critical task for stereo vision analysis. It is the process of computing the geometrical relationship between the two cameras in space. By selecting the Start Calibration button, it is possible to acquire multiple images of a calibration pattern, such as a chessboard, and to get the calibration process. The outcome is an estimating of the geometry of the cameras and of the distortion of the lens. These parameters are used to correct for distortion effects, and to construct 3D dimensional representations of the scene. The camera calibrated images are used to create a disparity map. By selecting the View Calibration button, the stereo images calibrated, and the disparity map are shown. The disparity map contains information relating to the distance of objects from the stereo system. To improve the disparity map, some settings parameters can be used. Collisions detection. By means of the Reset button, the main window appears. Here, the object area, which represents the load to be monitored, and the ignored area, must be selected. The collisions detection algorithm follows the superpixel aggregations, having the same depth respect to the object monitored. When an aggregation is near to red area, the VGS application reports a possible collision. To test the implemented system, a complex workplace has been used. This working area is a unit of a thermoelectric power plant. Complexity of the working area is given by the presence of many equipment and pipelines distributed on different levels. The prototype has been installed on an overhead crane. The installation is such as it always looks at the hook and, therefore, at the load and its surrounding. Here is shown how the VGS system performs in the selected case study.